Hi everybody, and welcome to the video on operator overloading in C++. Today we're going to talk about how to overload operators in C++ using as a guide the D.S. Malik chapter 13 book on C++ programming. So any references from that book can be found on chapter 13. So let's start by talking about why we need operator overloading in the first place. So far you've been using built-in data types like integers and floats and doubles to do certain operations between them. For example, if we wanted to add two integers together, such as like int x, or let's see, int I and j, and we wanted to add them together, you can do something like I plus j. Similarly, if you wanted to multiply them, you would do this. However, if you wanted to divide them, in this case, this is known as integer division, which we know that it's going to basically not just round, but it's going to cut off the decimal part of the solution. And if you want to know what that is, it's actually what's on the remainder using modulus. So these are all operations that work on built-in data types. However, if we have a class, suppose we have a class A, like this, and this class A had an integer x in it, and we wanted to divide two objects of class A, so like my A, and then we had my A2, and we said something like my A, or not just divide, but let's just say add. If we wanted to do something like my A plus my A2, the compiler doesn't know how to handle this because this isn't built in. Now, we might be thinking, okay, more than likely what he's trying to do is take the x in my A, the member variable x, and add them together. So maybe something like that. But that's just my interpretation of what that addition is supposed to do. Perhaps it's not even an addition, it's a subtraction, even though we want to be using the addition operator. As we will see when we talk about operator overloading in a second here, this is one of the big risks and why I personally don't like using operator overloading, because it can change how your code is in terms of readability, writability, and reliability. So with that said, how can we do something like this using the syntax that we're familiar with? Well, we're going to take these operators that already do certain things and we're going to overload them. We're going to add functionality to them to be able to handle user-defined data types. So to do this and to show you in detail more of it, I went ahead and created a simple class called coordinate, or just coord. Let me briefly go over the functionality of this class, and that way we can play with it and overload some of its operations. So first of all, we're using IOStream because we want to be able to use scene and cout. And then this class has two private variables, x and y, which represent a coordinate system, x and y. And along with this, we went ahead and created a bunch of accessors and mutators. We may not use them, but I just threw them in there in case we need it. Basically, that we can read what's in x or change what's in it if necessary. I also have a little constructor here that initializes x and y to 0 or to whatever is passed in as a parameter. Finally, we have a print and a read function. Our print function is just going to print out the coordinates using some nice little formatting, and the read is going to read in from the standard input the x and the y if they're fed in that order. So with that, we create a class, and now we can look at the main and we can see that we create two of these points, and for each of them we pass in a specific value. So the first point, x is 7 and the y is 2, and for the second one it's 42 and 21, and then we have a third one where we don't pass anything, so we expect that to be 0 initially, but then we read into that point, so we're reading from the user, then we'll print all 3 points, and then we print out some nice message. So let's just make sure that this still works. Well, it compiled, and now we execute it, and it's asking me to enter coordinates x and y because in the read function I put that prompt. So let's just put in some random numbers. It doesn't really matter right now what we put. So, we put that in. And as we can see, we get 7 and 2 for the first point, which is the A. Then we get 42 and 21 for the second one. And then we get the 6 and 6 on the third one. So everything works as it should. Great. Okay. However, what does not work is if at this point in time, and for now I'm going to comment out the read so I don't have to keep entering values in. So, we'll leave it just like that. So, obviously now it's just zeros. But, okay. Suppose that I wanted to do something like, well, I want to be able to add a plus b. Lowercase a plus b. And maybe store that on C. Okay? So, of course, if I do that, I'm going to get a compilation error saying, error no match for operator plus. Operand types are chord and chord. Okay, let's take a closer look at what this error is telling me. First of all, let's talk about the word operand. So, in math and also in programming, an operator, you could say operates on operand. So something like a binary operator, such as plus, is known as binary because it has two operands. So the syntax tends to be operand, then we have an operator, and then an operand. This syntax applies to any binary operator. In this case, the plus is here, this is the A, and you can think of this as the B. In the case of a unary operator, there can be two possibilities. It could be operand operator, or it could also be operator operand. This can be something like a star for some reason, and then this could be something like, well, actually a more applicable case would be a plus plus, and in this one it would be something like plus a or just negative a. This of course is known as post increment, and this is simply a conversion into a negative of whatever a is, or if we did this, then it would be pre-increment. So these are known as unary operators. So unary operators, and then this is known as a binary operator. Okay, cool. So in this case, the error is saying that the operand types, so the A and the B, are coordinate and coordinate, and that's true. A and B are of a user-defined type known as coordinate, because this is what the class is, right? That's what the class name. So this is correct in saying that the operand types are that, but it says there's no match for operator plus. What this means is that the addition operator, that is a binary operator, does not have a code in there to be able to handle adding two types of coordinate. It knows how to add two integers. In fact, suppose that one of these I change into just a number like that. And then if I do this, I'm going to get the same error, but you'll notice that on the right side here, I'm getting integer now because this is an integer, or at least that's what it's interpreting it as. So again, there is no match on how to add an integer and a coordinate. So as you can see, it checks the type, and if the types here have something that is matching, such as if I did something like that, well, then it would be, well, it wouldn't be okay right now, but if we just did something like that, then it would be okay because it matches. Let's try this and see what error we get. As you can see, this one is like YOLO, but let's not worry about this one for a second. We'll come back to that. But for now, let's try to do the original case, which was this. Okay, so here we have this problem. So how can we overload or change what the addition operator can do to handle this? And there's two main ways, and I'm going to show you first what's known as a member function that overloads the operator. So what you do, and the basic syntax for this is as follows, and this is right from the book. I'm going to copy and paste that line right here, and we'll actually see if copy and paste works like this, because this is running a VM right now. There we go. It worked great. So we can actually leave that as a little comment above what we're going to type. So the syntax for for overloading an operator inside a in general, actually, just in general for overloading an operator is going to be, first you have your return type, which can be anything from built-in data types to custom data types. Oh, and here we have people from the Discord asking questions. I will get to your questions, but not right now, so closing that for now. Shout outs to whoever that was. Anyway, so as I was saying, the return type for any operator can vary. For example, with division, depending on the parameters, the return type is going to change, right? So if you have integer division, you're going to get actually an integer. However, if you have integer like it's a division between one integer and one non-integer, then you're going to get potentially a double out of that, or something with a fraction, right? So you can also do something like potentially have two operands return a completely different type back. So like I could make a coordinate added to an integer return an integer, a coordinate, or even a string, as you'll see, which is a little bit ridiculous, but you can do that. Somebody in class asked that, actually, like, could you do that? And we tried it and it worked. So return type can be anything you want. Then you put in the keyword operator, just as you see here, and then you put the symbol that represents that operator. As you will see, not all operators can be overloaded, but those that can be typically are managed with a symbol. In this case, for addition, it's the plus, which is pretty straightforward for most of these. The division is going to be the slash, the minus is the forward slash, the minus is just a little dash, and multiplication is going to be your asterisk, and so on. So that's what the operator symbol is, and then you just have your formal parameter list, like such. Great, so let's go ahead and do that for the addition. So in this case, our addition for the coordinate type is going to return a coordinate with the corresponding result. So that's what the return type is. Then we put the keyword operator, and because C++ is white space insensitive, I can either put my operator symbol next to it or with a space or like that. I think it looks nice like that. And then our formal parameters. So in the formal parameters, because we're doing a member function here, we're actually going to put only one parameter for a binary operator on this case. And that is actually going to be the left-hand side. So the left-hand side is going to be this operand, which we are saying is going to be a coordinate. It's going to be the b. So we're going to put the type coordinate, and then we're going to put the just a it doesn't have to be the matching b. We'll actually, to make it a little bit make more sense, we'll call it the right side, like that, or just right. And you know, you could do this outside and not an inline function, but for now we'll just make it an inline function. And so now here you can write whatever, any code you want. In fact, I could write code that does nothing related to addition. I could literally write a function call that says like I'm Timmy, I don't know, just for fun. And if I just leave it like that, well, I need to have something that return, right? Because I made it here return something, but you know, I can just kind of say that it returns the right side, and you know, I'm pretty sure that unless I did some other typos, like, you know, that's going to be okay for the most part here. Let's see. Oh, I forgot to save. There we go. So, oh, that's right. I didn't put using namespace, so I have to put std in front of it. Let me just put using namespace to save some typing. Namespace std. There we go. Okay, great. So as you can see now, when this operator gets called here, you actually get that I'm Timmy. So operator plus says, hi, I'm Timmy, basically. And then it returns to you the right. So even though it returns to you the right, I printed before I did that. So if I go ahead and put that over here like that, then you will see that it contains the right side. So all I'm doing right now, I have actually overloaded the operator, but all it's doing is basically returning what's the right. So a plus b is always going to be, the answer to that addition is always going to be b. And just like any addition has a result to it per se, like 5 plus 2 is 7, and any number plus any number is going to give me some number back. Now, math people might get a little finicky about that, but I'm just saying in general, for most of us humans, it's going to give us a number back, right? Similarly here, it's going, you expect this addition to give me something back, and that's how I have coded it. All it's going to do is going to ignore A and give me B back. That's not very useful, right? But it is technically the semantics that we've created here. So let's make this make a little bit more sense. So first of all, let's not make an operator print random stuff out. So let's get rid of that. Let's create a, to not change any, even though we're passing by values, to not make it confusing, let's create another coordinate called answer, and then we will return that answer when we're done working with it. And how about this? I think it makes sense that when we add these two guys together, what we're going to do is we're going to add the x's together and we're going to add the y's together, and that's going to be our addition. So to do that, to take the right side, all you have to do is basically, well, you don't have to use this pointer, but if you want to make it clear, you can do something like that, like this x plus the right x, and we're going to store that value into the answers x. You can do that for sure, or you can also just simply say answer y gets y plus right y. Great, so now this is a little bit better of an overloading. It should be answer, not answers. Look at the compiler doing such a good job at telling us actually meaningful or error messages versus what it usually does, right? Okay, so now let's see if this worked. Okay, it took the first coordinate here and the second coordinate and added them together. So 7 plus 42 is indeed 49, and 21 plus 2 is indeed 23. So it worked. Now look how cool that is. I can just add things together and print them out. Okay, great. Now let's go ahead and do the subtraction. To do that, copy and paste, change the operator to a minus, and then you gotta change what you do inside. So maybe you make that a minus, and maybe you forget to make that a minus, and then you go ahead and enter it and then run it, and then you're like, okay, did this work? Well, I don't know. Did it work? We have to actually write some code that'll tell us if it works by calling the minus. So now we're like, okay, let's see if this worked. Okay, well, we're taking the a minus the b, so we're taking this minus this. So 7 minus 42 is indeed negative 35, but then 2 minus 21 is 23, and you're like, what? And so now you spend the next 10 days without food and water, just sitting there staring at code, hoping to find out why a subtraction is not working. And then on the 11th day, you look at this and you find that it was a plus there when it should have been a minus. And now you cry a little bit, and then you come back and you finally run it and it works, and you're so proud of yourself. And this has happened to all of us. Maybe not that extreme, but at least that's what it feels like to us. And so this is the biggest problem with, in my opinion, with operator overloading. Well, it's not just operator overloading. It's in general when you're programming. But I feel like operator overloading prones itself to more of these kind of problems. You have to be very, very careful that you don't make any logic errors when you're overloading it. And furthermore, that when you do overload an operator as part of a class, that it is something that makes sense. Because, okay, here, very, baby example, addition, it makes sense to add the x's. Subtraction, it makes sense to subtract the x and the y's. And I'm pretty sure that if I did multiplication or division, they would all be relatively straightforward. The problem lies when you have something more complicated. What does it truly mean to add something? And that's meaning that you're giving it, right? And so what you think is very clear and obvious when it comes to what an addition means may not be the same thing that somebody else thinks. And so therefore, If you don't document your code correctly, and even if you do, there's people that will just look at this and they'll be like, well, that's supposed to be subtracting something, and maybe it's not. Maybe you messed up, or maybe you didn't mess up, but it just, you do something in a different, what other people might interpret as subtraction, and that just becomes a very, very hard thing to work with. Let's verify, by the way, that this is still recording. Okay, so it's still recording. Great. Otherwise, I'm just talking to myself. So, anyways, that's the basics of operator overloading, which I think most of you saw in class. But now let me go ahead and show you another way to overload the operators. And so, for example, let's go ahead and do the multiplication operator. Now, of course, you could just do this, you know, copy paste it in here and then switch this to multiplication. And then, you know, instead of, you know, maybe you do it like that now, right? But actually, you know, before we get to that, let me show you something else. Let me make it so it doesn't necessarily return a coordinate. Suppose that in your world, the multiplication is like a kind of like a vector thing, multiplication or something, and instead of returning a coordinate, all it really returns is a double. You can do this. And so now, you know, if I want to find out what that is, I can do something like cout, because it's just a double. You know, if I try to just cout something like a class, I get the big scary error, right? We've all seen that before. So, however, if I do something like a times b, that's actually just a double. So, because it's a double right now, it's complaining because, you know, I'm putting it into coordinate. So let me go ahead and simply say, okay, maybe that gets multiplied and then that gets added to this multiplication. Like such. Okay, so now we get 336 there. Let me put a little line feed. Like such. Great, 336. So I don't know if that's correct. I don't feel like doing the math, but you can at home. It should be basically that times that plus that times that. You know, that's basically 42 there, and that's I don't know if that was 50 times 7, 5 times 7. Yeah, so that seems about right. So actually, it seems a little low, but I'll have faith in that. Anyways, the point is that, okay, suppose that I wanted to do an operator in a different way, and that is as a non-member function. You can do that. So you can go ahead and use the same syntax here and just dump it out here. And so let's suppose that we're going to do the division. Okay, and we'll do it in the same manner as this guy. In fact, why don't we do this exact same one, this multiplication right here, like such. So let's just take that same exact code right here. In fact, we'll put it in one line so we can just comment it out. So we'll take this exact same code and we'll do it outside the class. And we'll, of course, comment it out from there, so that we don't have ambiguity, because that is one thing that can happen. If you overload the operator, you know, it's like any function overloading, in the sense that you can have as many functions that have the same name as long as they have different signatures. So like if you have a void foo function, such as like this, you know, if you have a void foo, you can't have another function that is called void foo that has an integer, and then maybe another one that has 2 integers. And you might even have a foo that has potentially a double. And all of these are great as long as there's not an ambiguity in the function call. So like if you have another somewhere here, a foo that has an integer like that, then this is definitely a no-go, because you're redefining a function. And then of course, even in these cases, you might run into problems where, you know, if you have a function that is something like int double, you know, and then you have another one that is like double int, you know, and then you throw in like some numbers in there that are like 2 doubles basically into this. It's like, who do I call, right? So that's the ambiguity with function overloading. Same thing happens with operator overloading. You cannot have ambiguity in that sense when it doesn't know who to pick. So anyways, back to this. Okay, so we're making this function outside. However, as it is now, it's not going to work, right? Because as we all know, basically, well, first of all, there's two things we need to do. Because it's outside, it's no longer a member, right? So we're going to a member function. So there's no this pointer or reference to the object. So therefore, we need to go ahead and give it a right and a left. Left and a right. Like that, right? And so basically, then, you know, we have to put in here left x times right x plus left y times right y. However, we're going to run into a problem, right? And that problem is that they're privates. X, and y, they're all privates. Okay. One way around this, if we have that function available, is we can use the getters and setters, right? We can do that, and we can do that, and basically they're all public. So then, you know, this works just fine, and it still gives us the right answer, right? But of course, very rarely are we going to have functions like that, you know, depending on the code. I'm saying basically we may not have an accessor function that can access these private variables. What if we don't have this function? What if we only have, you know, we don't even have the setters, like we just have a read and a write like that, you know? If that's the case, then of course well, right now we'll say those functions don't exist. But basically, we can't do anything at that point. So what can we do to get the private variables? And you're like, well, then just make it a member function, right? Yeah, but what if I don't want to make it a member function? Is there a way that I can still keep this as a global function and be able to access private variables? Well, you know, you can get all hackish and use the bolt assignment that I showed you guys, in sense of, you know, doing some nasty stuff here, such as reinterpret casting and using pointers to get access to private variables, using the pointers to the left class, and, you know, nasty stuff, such as maybe I can actually, I really shouldn't, but I kind of want to try to do it on the go here. Get the address of that, and then basically go ahead and reinterpret cast that as an integer pointer, and then dereference that, because the x is the first variable. That should be on the same address as the this pointer. Oh, I changed that one here. I could do this for all of them, but I just want to do it for one of them, just for the lulz. You know, and there you go. Ha ha ha. How cool is that, right? That works just fine. Quite scary that it does, doesn't it? In fact, I can do the same thing for this guy and change that to right. And then for this guy, I have to do left, and then maybe like +1. There we go. And then the same thing. Now I'm getting really off topic, right? But you know what? It's a video, you can fast forward through this if you don't want to see it. It's a good review for the test. So yeah, there you go. Disgusting, right? But and it works, you know, like it's kind of disturbing in a way. But yeah, so this, I guess this is one way to do that and not have to worry about it. But okay, suppose you don't want to do this sort of evil thing. I mean, reinterpret casting is not the best of tools to use, right? I mean, you know, if your boss had this code, it'd be like, okay, there's the door. Don't come back. So anyways, okay, so let's save that for posterity reasons, and then undo it. Okay, Good enough. Okay, great. And now we can bring this back and just leave it commented out. I will go ahead and post this code for you guys on Canvas and maybe on YouTube as well, in case we get like a random stranger looking at this. You know, it might be help them in their own classes. Best of luck to you, strangers. So yeah, okay. So we have the dilemma that we're trying to access the private variables without using something that nasty, right? So there is another way. There is another Yoda. So there is a way that you can access private variables so that I can still use the same syntax here as if it was part of, as if they were public variables, right? Because this would all, oh, what have I done here? This was X and then this was X. You know, if these were public variables, if I went ahead and commented that line of code out, the private thing, you know, this would work fine still. But of course, there's that. So what I can do is what's known as a friend function. So friend functions are global functions that are basically a friend to the class, and because they're friends to the class, they have access to the private variables. So if you remember that little chart about like who can access privates, protected and public, I said, okay, the class itself can access any of its own private members, protected or public. If you inherit that, if you derive that class, the derived class can only access the parent class's protected and public variables, right? It cannot access the private variables, and so on. Okay, well, with friend functions, they are basically friendly enough per se that they can access the class that they're friends with, public, protected, and private variables. And so you can think of this as having a friend roster, kind of like a Facebook friend roster, where they keep all their friends. So whenever this guy is trying to access these private, you know, they check, somebody checks whether they're on the friends list, and if they are, they're like, yeah, sure, go ahead and access them. And not just access them, but they can change them as well. So they have full read and write access. They are like full friends, like, you know, they're close friends per se. So how do I make this guy into a friend function? In this case, I am doing an operator, but this works for any function that you want to make a friend function. Whether or not it's an operator that you're overloading, it can just be a generic random function. So the way you do that is you simply take your prototype for your function, you put it inside here as if it was as a member function, but you put in the magical word friend. And so now this function is a friend of this guy. And of course you need a semicolon there. And so now it works. You are accessing private variables, and because this is here, it works. Let me just uncomment that again, or comment that so you can see we have the error here, the private. Now this is a friend function, and so now I can access private variables. Now, of course, this really, you shouldn't do this, but you can even change this like that, and that actually permanently changes it. So, you know, I'm not printing it, but if I went ahead and printed, who was the left side, the A? If I printed here a.print, you'll see that I've actually modified. Actually, no, because I passed it by value, so it's still there. But if I pass it by address, by reference, then well, I have to change a bunch of things to do that, but don't really feel like doing it. But yes, if you pass it by reference, then you know, you would run into the issue that this could modify it. But in this case, we're passing everything by value, so you know, we're all good. So anyways, I'll get some water for a second. These are friend functions, and so friend functions come in very useful because there are some operators that we cannot overload as member functions. We have to overload them outside. And let me give you an example of that. Okay, so let's sit back for a moment and close your eyes and imagine that you're coding and they tell you to do the following. You have to code a function that needs to access private variables from two classes. And because it's from two classes, that should automatically tell you that you cannot make it a member function of only one class, right? Because if you make it a member function of, like, let's say we have class A and class B, and I say, okay, you need to do a function that is just going to take a member from A and a member from B and maybe compare them and tell you if they're equal or not. But those member variables are private. So if you're like, okay, I'll put it on class A as a member variable. Great. Because it's a member variable of class A, you can access variables from class A. But when you try to access that other variable from class B, you can't because it's private, right? And so you were like, okay, crap. Great. So then I'll put it on B. Okay, so you put it on B. So now you can access the B, but now you cannot access the A. And you cannot just magically throw the same function on both and assume that, okay, it's in both, so I'll be able to access it. No, you can't. You have to pick one or the other. So you kind of reach the dilemma of, like, should I go with, I mean, what should I do at this point, right? Well, one solution is, of course, you can throw in your reinterpret cast and be evil, but, you know, we're trying to be good coders. So what you can do is you make it a friend function of both. So you make it a global function that is friends with both classes, and now you can access both A and B's private variables, and so you've solved the problem. So, okay, I guess open your eyes now, and I suppose that let me show you an example of that really fast. So let's just go ahead and throw that in. Right here. So, you know, let's make another class. We'll call it class temp. And class temp has a private variable. Well, we need to put private because it's private by default. You know, G. And so now I want to create a function that is going to print out, or it's going to be foo, that's going to print out whether an object of coordinate called A and an object of temp called T is going to print out whether the G is greater than the X. So G greater than X. Question. And so to do that, it needs to do A dot X greater than then T dot G. You know. So we'll put that in the if statement up here. How about that? If A is greater than G, then print out G X is greater than G. Yeah, there we go. That looks nicer. So semicolon, not there, but there. And of course now, you know, we get a couple of problems here. First of all, you know, this should be lowercase class, my bad. And so now, of course, we're saying that, you know, chord X is private and G is private, okay? So, like I said, we could put this as a function here, but we will only be able to access the G private. We want to be able to access the X, right? Or we could do vice versa. So what you can do is you can make it a friend function of both. So I can go ahead and take this guy and throw it here and make it a friend function like that. And then I can take this guy and also put it here and make it also a friend. So this is like a very popular function. It's got a lot of friends. And so now, no, oh shit, oh no, oh look, private. Did I not? Did I miss something here? Oh, 1 second. Temp has not been declared. Oh, I see. Yeah, my bad. So the error that I'm getting is the fact that the class temp is defined here, and because the code reads vertically like this, it sees this temp and it's like, what's that temp? And it's done here, right? So then you're like, oh, okay, let me put this up here. well, then you're going to get the problem that the coord is not declared. So you need to put a class prototype per se, like that, and that solves that problem. So in fact, do I need this in here? I don't. Okay, that's what I thought, but you know, I was like, maybe I do. So it doesn't matter that the friend thing is private. It's still okay. So, okay. Actually, we'll find out if we really don't need it when we do the call. But you know, we'll see. So we can do something like foo, and then pass it a coordinate A, which we can say, you know, A, and then we'll pass it a T. But I need to make that. So temp T. And there's no constructor to it, so let me put that in real fast so that, you know, it's not undefined here. So temp G gets 1. I don't need any of that actually. But yeah. But I do need the word public in front of the constructor. That is definitely something that I do need, because otherwise, well, you can see the compiler complains for a good reason, by the way, but that's, you know, beyond the scope of this. So yeah, okay, great. So I get that x is indeed greater than g, and it is because that is 7. So, but if I made this into 10, then I shouldn't get that printed out, and I don't. So great, okay. So that works just fine, right? So as we can see here, this is just a global function, but because it's both friends with both classes, I am able to access private variables from both classes. And that's the only way that I could have done this, unless I did some nasty stuff with retempcast. Great? Great. Okay. Now, why am I talking about this when the point is to talk about operator overloading? Okay, as I was saying, there are some operators that you can only overload if you're using the friend functions. And the most popular ones that you're going to run into are the reading and writing, so that's the insertion and extraction operators. You can only overload them using the friend functions. So let me show you how to do that. So right now we have this read and print function, right? Because we don't have a way of just easily saying something like C out A, or being able to do something like C in C. Well, now you will be able to. So let's go ahead and do that. So let's go ahead and do the C out first. So the syntax for that is also going to be this one, as such, and it's going to be something like operator. Sorry, my bad. It's going to be, in this case, we are going to do the OS stream. So OS stream, and then the operator, and that's the extraction operator, and then ampersand, and then the coordinate that we're working with, and this time we'll pass it by ref. So OS stream ampersand stream const coordinate. Yep, that looks okay. All right, so now we're gonna put that in as the friend function up here. And by the way, I should probably stop the video to split it into 2. So maybe I'll do that. So I guess watch part 2 for part 2.